right, 5.4 is about medians and altitudes. Theorem 5.8 talks about the concurrency of medians. And says the medians of the triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So when we're looking at the medians of the triangle, notice they cut each side in half. They all intersect here at point C. Okay, so we're going to talk about DC, which is this point right here, is 2/3 of the whole line DG. So the point to that midpoint is 2/3 of the whole. Okay? So when you're looking at the picture, that's important because when you're looking at the other stuff too, CJ then would be 1/3 of the whole, which is DJ. Okay, so we're going to use that to try to find things as we work on here. Right below, I gave you a concept summary of all the special segments and lines in triangles. Okay, so when you're looking at all the bisectors, okay, all the perpendicular bisectors, I'm sorry, that gives you your circumcenter. When you're looking at your angle bisectors, that gives you an incenter. Your medians give you a centroid, and that's what we were just talking about above here in Theorem 5.8, and the altitudes give you your orthocenter. Okay, and that's what we're going to learn how to find a little bit later too. So those are all the types of segments and lines in triangles. Problem 1 tells us they give me XA, which is 8. So XA is right here, that is 8. And they want to know the length of XB. So if I look at it here, XA is the long part of that line. So I'm going to talk about XA being, or 8 equaling 2/3 of XB. Okay, last one we had half. Mid-segment was half. This one is 2/3. And again, write the formula like this. That segment equals 2/3 of the whole segment. Okay, so 8 equals 2/3 of XB. In order to solve, again, you're going to go ahead and multiply by the reciprocal, 3/2, 3/2, and so XB should be 12. Problem 2 in A, they talk about triangle PQS. Now, R out here is just what they're dropping P down to, and we'll talk about that in a second. And they want to know, is PR a median, altitude, or neither? So when we're looking at that, one, does it come from a vertex? Well, PR comes from vertex P there, so yes, that's good. And does it intersect the opposite side at a right angle? Now understand, even though that it cuts here at point S, it can still extend out. And that's the definition here. So you drop PR down, it forms a right angle with the following side here, the opposite side. So therefore, PR is an altitude. These things do not have to be actually inside the triangle to be part of it. Okay, and now they want to know if QT is a median altitude or neither. So let's look at QT. Again, does it come from a vertex? Yes, it does. So it starts at a vertex, we're good. It goes to the sign PS at point T, and if I look, T is the midpoint of PS by the markings of PT and ST being congruent. So since it's in the middle, that tells me that QT is a median. Problem 3 is about finding orthocenters. They give us triangle ABC with some points. A is 1, 3, B 2, 7, C 6, 3. They want us to find the orthocenter. Remember, the orthocenter is where the altitudes intersect. Okay, so what I'm going to do is I'm going to come across a line that's either vertical or horizontal. And this line, AC here, is a horizontal line. So I'm going to go ahead and I'm going to drop my altitude from the point opposite it, which is point B. So right there is my altitude. Okay. What's the equation of that line? Well, if I drop it down, I notice that line's vertical. So that's going to have the equation x equals, and I look at it, the x coordinate of the B is 2. If I look on the graph, it's x equals 2. So that takes care of that. Now, I'm going to pick either one. It doesn't really matter. A, C, it doesn't matter what I do, but let's drop the altitude from A. This is right there. I want to find the point at which they intersect. Now, finding the equation of B, let's call it x, was pretty simple. I need to find the equation of A, let's call it y. So in order to do that, I'm going to find the slope of the line it intersects first, and that line is BC. So the slope of BC is going to be, we know that B is 2, 7. Let's write them up here so I can see them. And we know that C is 6, 3. So my slope is going to be 7 minus 3, over 2 minus 6, or 4 over negative 4, which is negative 1. If I want it to be the slope of AY, because that's what I need, it's perpendicular to BC, so again we're going to do the negative reciprocal, which would be positive 1. So the slope 1, and let's take a point on that line. Again, it really doesn't matter what we pick, but I'm going to take point A, which is 1, 3, and we're back to our algebra stuff. Y minus 3 equals m times x minus 1. And again, I'm just using this point right here to fill in my point slope, or this is my point slope formula. Okay, so let's solve here. Y minus 3, I would distribute the 1, but I don't need to here, equals x minus 1. Add 3, I get y equals x plus 2. Now, if you remember before, I had the one equation as x equals 2, and I have my other equation as y equals x plus 2. So I can really solve a system of equations here, but it's pretty simple. All I need to do is take the x equals 2 and plug it in to find my y. Okay, so x equals 2. I'm going to plug it into y equals, substituted there, always substitute in parentheses, plus 2, I get y equals 4. So this y equals 4 and this x equals 2, that's the point of my orthocenter. So my answer here to find the orthocenter is 0.2, 4.